Okay, in the last video we looked at this variable and we identified some outliers and we printed them out over here. Now we're going to do some other exploration of the data, possibly for different variables, and we want to use a package called lattice. So that may already be installed, but we can check to see if it's installed. Let's check load package and see if lattice is here. It is, so I don't have to go out and get it. So I can either click OK here, or I can do it like this. So now lattice is available. And now I'm going to run this command here. And this is also a box plot. It's just lattice's version of the box plot. And in this box plot, we're going to sort of, remember, size is one of the variables, and this one, and also A1 is another variable. So it's going to sort of make a box plot, but it's going to split it actually into each value of size. Remember, size has three possible values: small, medium, and large. So for the small values of size, we're going to get a box plot for all for A1, for the variable A1, and then for the medium size records, we're going to get a box plot for A1 and so on. So it's and this is just the labels, and here's the data from algae. I have to tell it where the data is. And now let's see what we have. So this is when the river size is small, this is the distribution of A1. When the river size is medium, this is the distribution of A1. When the river size is large, this is the distribution of A1. So we can see that for small rivers, this variable A1, which I'm not quite sure what it is, but is much more varied, much more spread out than, say, for medium-sized rivers or for large-sized rivers. And furthermore, not only that, but that this is the only one with a lot of large values. These have some large values, but only a few. But so we can say that for small rivers, A1 can have high values. So again, we're looking at two variables and sort of comparing them visually. Now here's another sort of similar type of plot, but here we can see kind of the distribution of the number of points. So we can see that the number of points decreases here. So we kind of get a numerical view of the distribution as well for each of these categories: small, medium, and large. So this shows a little bit more clearly the distribution of the variable being plotted, that is for A1. And the dots here are the mean values. So you can see where the mean value is. And the vertical lines, 1, 2, 3, are the first quartile, the median, and the third quartile. And these dashes here are the actual values of the data. And this is obtained using this package. So actually I tried to install it. I tried to load it, but it wasn't installed. So first I went to here and tried to load it, but it wasn't there, so I had to go to install packages, and then I found it, and then after that I could well, here I got the error when I tried. Then after that I could load it with this command, and then I created, using that one, I used this command. Now, I think we had bw plot before, didn't we? Yeah. So now we have two functions called bw plot because we have two different packages. Notice that when I loaded it here, some of the objects were masked, and perhaps that was one of them. So if you want to find out more about this function, you can look it up by using question mark and this name. Now I can say that this plot, or the one we saw before with the 3 box plots, is a kind of conditioned plot. In other words, we have the distribution of the variable given that it's small, or given that it's medium, or given that it's large. So when I say given, I mean that there's a condition that it's small, or the condition that it's medium, or the condition that it's large. So I can call this these conditioned plots. And you don't have to have you don't have to use this just for nominal variables, like small, medium, large. Is the river size is a nominal variable, and you don't have to just use a single factor either. But if you do have a non-nominal variable, a quantitative variable, like a continuous variable, then you need to discretize it first. So let's try all of this out. Let's look at the distribution of A3, the variable A3, conditioned on 2 variables, not just one, conditioned on season and another variable MnO2. And MnO2 is going to be a continuous variable, so we'll see how to do this. So let's do that in the next video.